Okay, collisions. So smooth sphere 4m. So A is 4m. Speed u. B speed u as well. And that's just 1m moving in opposite directions. Coefficient of restitution is E. Speed in terms of u. Each sphere after the collision, that should be fairly straightforward. And then impulse. Okay, impulse is kind of a new one, not asked terribly much. So speed of each sphere after the collision. So your Pacum is, okay, your momentum before, okay, we'll take that as the positive direction. So your momentum before is 4mu minus mu is equal to 4m VA. We don't know which way it's going to go afterwards, do we? Moving in opposite directions, we don't, so we're just going to, okay, so we're just going to leave them and we'll find out later, it'll pop out of the maths. So VMB, okay, and then now will be VA minus VB is equal to minus E times U minus minus U, which is that. Okay, so okay, so VA minus VB is equal to minus 2 EU. And up here, we've got masses cancelling on that guy. So we've got 4 VA plus VB is equal to 3 U. Yeah, okay. Add them to get the just VA. So get 5 VA is equal to, okay, take U out and we get 3 minus 2E. VA is equal to U over 5, 3 minus 2E. Lovely. VB then is equal to VA. So from this guy, VA plus 2 EU. Okay, so it's equal to U VA U over 5, 3 minus 2 EU over 5 plus 2 EU. Okay, so it's equal to 3U over 5. And, okay, so what's that? That is 10 EU over 5. So it's plus EU, 8 EU over 5. So VB is equal to taking out U again over 5. And we get 3 plus 80. Okay, so quite similar structure to each of those. Okay, magnitude impulse on B to the collision is T. So impulse on B is T. Okay. Now the impulse is equal to the change in momentum. So it's equal to momentum afterwards by momentum before. So B is the midget one, isn't it? Just M, yeah. So M VB minus MU, yeah? Now, do we know which direction it's going afterwards? Okay, so that, well, okay, hang on. We don't need to worry about it yet. Okay, that has to be positive. So VB is going in the negative direction again, but we can work that out later. Okay, so it's equal to m into u over 5, 3 plus 8e minus m, which, no, sorry, minus u. Okay, so it's equal to mu over 5 into 3 plus 8e. No. Yes, it is, yeah. Okay, u over 5, so that it'll have to be minus 5u. So IB equals mu over 5, 3 plus 80 minus 5u. Okay, so that's the change in velocity. Okay, have I gone wrong there? Okay, velocity or momentum afterwards is m times the velocity afterwards minus the velocity before. Okay, grand. The momentum before, which was that. Hang on out. So that was negative. So that needs to be positive. Okay, so that should be positive in that direction. Okay, so that's the slip there. That should be positive because it's double negative. Okay, so now the impulse then. So you get your equation for the impulse, and then you know that the coefficient of restitution has between 0 and 1, which then gives you the restriction for t. So that will constrain it that way. Okay, so yeah, so can I add those two? All right, so IB now this time is equal to m into 3u over 5 plus 8 EU over 5, and now we're adding u. Okay, so it's equal to mu into 3/5 plus 5/5 is 8/5 plus 8/5 e. Yeah, okay, seems to be coming out kind of even enough. Looking kind of promising. Not that being even or looking clean is anything to do with it, but 1 plus e. Okay, so now we know that e has to be between 0 and 1. So these lads then have to conform with that as well. So, okay, if e is 0, then IB will then be equal to 8 over 5 mu. Yeah? And if e is 1, then IB will be equal to twice that, so 16 mu over 5. I'll be surprised if that's correct because I've been around the houses there a little bit and it is. Okay. All right, so yeah, so that's the case if E is 0, so the impulse has to be bigger than that y, and then that's the case if E is 1. So interestingly, it's bounded by factors that are twice each other. So that figure is twice that one. Okay, so that's that one. That was a little bit tricky now. I found that a bit tricky. Not used to doing the impulse figures. So you're subtracting the momenta before, after and before, but okay, it came out all right, thankfully. Okay, these guys obliquely, okay, angle of 30 degrees, and then afterwards it's 60 degrees. Coefficient of restitution between the spheres is E, show that K is equal to this lad, and speed at Q immediately afterwards. Okay, let's have a look at that. Alright. P and Q. This lad comes in here and he goes off there at 60. Bit of snooker going on. Smooth fear, that's 2M. And that's mass M. This is coming in nicely at just KU. Okay. Right. Oh, and that is 1U. Alright, nice one. Angle of 30. Okay. Shot at K. Alright, so let's have a look at this. So, and of course the law really for oblique guys is that the J direction velocity is preserved. So it doesn't change. And then all your equations are in the I direction. So it's along this axis that all your Pockham and your Nell happen. So, okay, so U of P, and let's go the 30-degree triangle. So that is 1 root 3, 2. So U of P is equal to cos 30, which is root 3 over 2. U root 3 over 2. I, and it's positive J as well, so that'll be sine 30, so a half of U. J. U of Q is nice and easy. It's equal to minus, and that's the crucial one there, minus KU in the I direction. Okay. Interesting that that velocity, the J will be preserved, so it can't have any J in the afterwards either. So it'll have to be like a snooker ball, probably going backwards there. All right, so V of P then is going to be equal to, well, let's just do our Pockham and all this kind of stuff. Okay, Pockham in the I direction is going to be M of VP minus M of VQ is equal to M of UP minus M of UQ. Okay, so this should be the easy one down here. So what's your mass of that? It's 2M of UP. So U root 3 over 2. And this is purely in the I direction. So minus this lad here. So it's 1M and it's plus. Hey, now Pockham should be pluses. Okay, watch that, man. So that now is a minus, yeah, because it's the MKU. Okay, so that is now, this side is 2M VP plus MVQ is equal to this lad. Alright, so 2 VP plus VQ, so getting rid of the M's, is equal to U root 3 minus KU. And we can bring U out there as well, probably. So U into root 3 minus K. Alright, box around that, be proud of it. Hopefully it's right. And Nelly then is equal to VP minus VQ is equal to minus E times UP minus UQ. Now let's get the bloody signs right. Minus E into UP, which is this lad, U root 3 over 2 minus UQ. So it's now minus minus, which is plus KU. So VP minus VQ is equal to minus EU into root 3 over 2 plus K. All right. And what do we have to prove? Okay, prove that k is equal to this lad. Alright, so, well, we can add those two simultaneous equations and get 3vp is equal to u root 3 minus k minus eu into root 3 over 2 plus k. So that's 3 of those lads. Okay, so can we simplify that further? Oh yeah, the direction makes an angle 60. Alright, so even more. Okay, so we've other things to consider there. So u, okay, let's take out u in there. So we get root 3 minus k minus e root 3 over 2 minus ek. Alright, so vp is equal to that. And vq, should I get vq? Are we asked for it? We're not asked for it. But, okay, we can, yeah, it's only vp that we need because we need to get this right here, this angle. Okay, so the angle of, so we have this, so vp, and that's the vy portion, that's the vx portion. Okay, the vx portion is unchanged, or sorry, the vy portion is unchanged at u over 2, and this vx is equal to this monster here. So tan of 60, let's see what tan of 60 is. Probably something handy, yeah, root 3. So tan of 60 is equal to root 3. And that is equal to basically, okay, the y is up here, u2 over this monster. So u over 3 into, okay, bit of root 3's here, which will hopefully help out. Root 3 minus k